Hello everyone, we're going to learn how to calculate derivatives in this video. So given a function, this is the equation we would formally use to find derivatives in calculus. But maybe I'll go over this equation in some other video. Instead, in this video, we're going to go over the shortcut to finding derivatives, which is what everyone basically uses. So let's first start with the function y equals x raised to the nth power, or f of x equals x raised to the nth power. They're the same thing. You can call your function whatever you want. For example, you can say g equals x raised to the nth power. But I'm just showing y and f of x in this video since these two notations are the ones used most frequently. And of course, y and f of x can be different functions or different equations. But here in this video, y and f of x are the same functions. Like I said, I'm simply just trying to show different notations. If you're not familiar with functions, then for now, just think of these two functions as equations, okay? So you have equation that says y equals x raised to the nth power, for example. Also, if you're confused by the exponent n can be any number, for instance, 2. Okay, then coming back, given a function, the question for us in this video is, what is the derivative of y or f of x? Some other people may ask you to differentiate y or f of x. Both are asking you to do the same thing. Also, some questions may add with respect to x at the end. If you're not yet comfortable with calculus terminologies, for now you can just replace the term with using x. So the question is basically asking us to find the derivative of y or f of x using x, which makes a lot of sense because in this video, both y and f of x are functions of x. Both of them are expressed using x. So now, in order to compute the derivative, we first need to focus on the exponent. And what you're going to do here is you're going to bring down the exponent and multiply it to the term with x. Also, you're going to subtract 1 from the original exponent. So we still have the exponent, but you're simply going to subtract 1 from it. At the end, as you can see, we get the term that says n times x raised to the power of n minus 1. And that is the derivative of y. So for example, if n equals 2, then the function would be y equals x squared, and the derivative of y will be 2 times x raised to the power of 2 minus 1. And all of this means that the derivative of y is going to equal to 2 times x if the function is y equals x squared. And that's basically it. You have just now calculated the derivative for our function. Also, we have notation for derivative of y, which we write shortly as y prime. For f of x, the notation for the derivative we call f prime of x. So we have now gone over some basic terminologies and methods to calculate derivatives. Of course, intuition for these derivatives is much more important, but we're going to cover that in a different video. Now let's quickly go over an example. Suppose we have a function y equals 2x raised to negative 3 minus 7 times x plus 3. So here, what you're going to do is you're going to apply the differentiation technique to each one of the terms in this equation. So remember the technique that we just went over to find the derivative of y? Well, you're simply going to apply that technique to each one of these terms one by one. And if you do that, then you're going to find out that y prime equals this term here in the middle. If you're wondering why we get 0 for the number 3, note that number 3 can be expressed in this way so that when 0 comes down and is multiplied to the term, the entire term simply becomes 0. So then putting everything all together, we get this equation that says that y prime equals negative 6 times x raised to negative 4 minus 7. And this is the derivative of y. Or if you want to be really technical, you can also say this is the derivative of y with respect to x. Keep in mind that if you have a more complicated function, for example, if you have something that looks like this, then you're going to need some special differentiation techniques, which we can cover in some other videos.